One of the most popular topics over the past few years has been chaos engineering. And two experts in this are from Gremlin. So please, can you introduce yourselves and tell us, what is Gremlin? What do you guys provide?
Hi there, my name is Anna Medina. I'm currently working at Gremlin as a chaos engineer. Gremlin is a chaos engineering platform for enterprise. We offer a very easy platform for companies to start doing chaos engineering experiments.
Hi, I'm Homing Lee, and I'm Solutions Architect at Gremlin. I'm part of this customer success team, so I work with a lot of customers on helping them build more resilient systems.
And for those people who are just not familiar with what chaos engineering is, can you give us like an overview? Why is this so important?
Sure. So for what chaos engineering is, essentially you want to proactively and intentionally inject some faults in your environment so that you can learn and you can experience it, and then you can build resilience over time.
So a lot of people say, well, I already do unit testing, I do function testing. Isn't that enough? Doesn't that cover everything? And how does chaos engineering help fill the extra gap?
Sure, I've done some testing in the past. I have some QA background. I think a lot of people, when they think of QA, they're doing functional testing, right? Mm-hmm. Testing that it works. They're doing some load testing where you're hammering your systems with load, but they're still testing against this perfect scenario. A perfect scenario where just nothing breaks. But in reality, that's never really the case, right? So you also want to test scenarios where you have hosts going down, you have bad disks, you have sometimes some slowness in your network. All these, just because they happen in production, you should actually get in front of it, proactively test these to learn from these failures.
And so Gremlin's been around for many years. What are some interesting kind of discoveries some of your customers have had using Gremlin, unleashing these gremlins into your environment?
Yeah, I can share, I'll start with a pretty basic story. I think a lot of people are moving towards microservices, right? So the good thing with microservices is you can scale components individually, but there's also added complexity. There's a lot more communications between services, so there's a lot more reliance on the network. So a common thing people test is what happens if service A suddenly can't talk to service B, or even just having delays, right? Like normally it responds very quickly, responds in a second, but sometimes because under heavy load, because there's just some degradation in the service that you talk to, there's slowness. And so you would then intentionally inject some delays in the communication to hit those retries, get to those timeouts, to actually experience it, to make sure that you know what that end user experience looks like when that happens.
So Anna, a lot of people might say, well, I don't want to risk breaking anything in production, right? I worked so hard getting this in perfect shape, I don't want to impact users. How do you convey that message effectively? Why should people be doing this?
Yeah, so we talk about something called the blast radius. So the end goal is to actually be doing proactively running chaos engineering experiments in your production environment, and also get to a point that you actually have put this into your CI/CD pipeline so everything actually flows extremely well. But before you actually get there, you actually it's basically like, why run an experiment on 20% of my infrastructure when I actually don't know how it behaves on 10% of my infrastructure? So basically the same concept of why run an experiment on production when I'm actually not sure how it actually behave on my environment closest to production, whether that could be like test, dev, QA. So we talk a lot about starting those chaos engineering experiments early on in a more controlled environment where you're actually able to not necessarily impact customers right at the beginning. And you slowly start increasing those experiments as you start seeing them succeed, and you notice that your systems, your infrastructure, your services can actually handle those experiments going on.
Now, how do you convince your business that this is something you should be doing, right? People already get upset if the site starts loading slowly or it's not performing correctly. How do you tell them we're going to be breaking this and that's a good thing? How do you get buy-in from them?
So part of it is it's going to break anyway. So why don't you actually break it in a controlled sense where you're actually able to be right next to your laptop that you can triage that possible incident that's about to start happening, or you have your monitoring in place before you do chaos engineering. So you also have a lot of like safety guards all around this, that there's easy ways to prevent outages to happen, like as you're doing chaos engineering experiments. And at the same thing, like for like some chaos engineering platforms such as Gremlin, we offer a way that you can actually stop an experiment immediately. There's even a button that's like if you're running more than one experiment at the same time, you can stop all experiments. And you can even set it up in a way that like if you have an API baked into your chaos engineering platform, it can actually just be like a monitoring threshold, actually triages that attack from actually stopping. And you know that you're actually not going to be causing any more harm.
I like that. Yeah, so perhaps a Gremlin does more damage than you're expecting. And so this allows you just to halt that process and bring production back up in a perfect state.
Exactly. I think part of the challenge is that people don't understand there's the ability to control chaos. It's kind of an oxymoron, right? You have control and you have chaos, but you're doing it in a very controlled environment, right? Yep. You sort of have, we like to take a more scientific approach to running chaos experiments as well, where you have a hypothesis of what's going to happen. And what you're doing is in this controlled environment where we're going to run these failure injections, run these attacks in the environment to then experience it and then see the outcome, see whether or not it matches your hypotheses. And then from that, if there's gaps, you can build gaps, but it allows you to really, in that controlled environment, in the right mindset, actually experience it.
Oh. And so, I mean, the best thing about that is you're no longer learning at 3 o'clock in the morning new things about your infrastructure, new things are introduced, because you're probably much better at learning at 9 or 10 in the morning when you have coffee. So that control environment lets you be much quicker at responding to it, fixing it, and patching it permanently.
Yeah.
What are some ways that you can introduce chaos within your environment? Like what are some, I mean, obviously you can take a server offline, but there's a lot of other nuanced ways. So can you talk a little bit about the wide range of ways you can harm your infrastructure?
You want to take that?
Yeah, so like a little bit about like the Gremlin platform is that we actually have 3 different levels of attacks you can run. You can run state attacks, and that actually means like shutting down a host, shutting down a container, or a process killer where you're actually able to give us the name of the like process and we'll actually just go ahead and kill it for you. Like how does it actually behave? How does it affect the rest of your system? Then we move over to the like network layer and we can actually black hole all traffic to like a certain port or just the entire like service. We can inject latency, we can drop some packets, we can actually triage errors in like DNS. And then state, what's the other layer?
You covered
state, network,
resources.
So one of the most common ones, like we talk to companies a lot about like certain outages they've had or like some of the most pains that they've had, and everyone knows what it's like to fill up a disk just because your logs didn't get rotated properly. It happens.
Which is like probably the #1 reason why most sites go down is the hard drive fills up somewhere and it ripples out and starts impacting everything else.
So we're able to reproduce conditions like that. We can maximize a disk, we can maximize CPU usage, we can maximize I/O, and even memory. So how does that even handle it? And things like that, you're able to even get to the point that you run different attacks at the same time and you form a more complex experiment. So you're even like thinking about more edge cases. Another way that I actually like talking about chaos engineering is that you're able to go look at past outages that your company has had, be able to see like, hey, what has hurt me the most in the last 6 months? Let me go look at that post-mortem I created. Let me go see the action items that I said I was gonna go do. But you never really like know if you actually put them in place until you wait for that next outage to happen. Well, why wait for that moment when you can actually get those conditions from your last outage and be able to create that scenario again and actually see that all the engineering work that you have put in has actually like been for a good reason.
So, I mean, for the Twitch viewers, if you have questions, if you're curious about chaos engineering, if you're not sure if it's right for you, please post questions. These are 2 experts. They've dealt with companies across every industry implementing gremlins who are just tearing apart these architectures. What do you say to people who are wondering how big do you have to be for you to start adopting chaos engineering, or I'm too big to adopt chaos engineering. What's the right size?
Yeah, we get a lot of people saying they're not ready, right? But I think it's one of those things where you're kind of never ready. There are some things that you do require, right? You should have some monitoring to actually see what's going on. You should have incident management in place. But this allows you to do this end-to-end, right? Like you're injecting faults, you are then observing what's going on, and then you have some way of handling the situation, whether it's code or people, right? So this actually allows you to test everything from the system all the way to people using runbooks to fix your issues.
And so Anna, you did a session Monday with Adrian Cockcroft from Netflix, now over here at Amazon. Can you give us a little summary? Like, what are some of the topics you talked about? What did the audience resonate with in your session?
So it was a great session. You should definitely check out the YouTube if you didn't get a chance to come to the session. Adrian and I decided to split our time in talking a little bit about the overview of chaos engineering, where it came from, how it all got started, and what are some of the tools that are out there to actually help companies start running chaos engineering inside their companies. And that was like a very cool experience because like we guided them from like other concepts such as like the blue-red team like concepts and like how do that actually like relate to chaos engineering to, hey, isn't disaster recovery testing very similar to chaos engineering? And it's like we're going above and beyond that and forming this other like expertise in engineering that you're actually able to do a little bit more in. And then I got to do a demo. So I was actually able to like set up an EKS cluster. I used like the AWS Getting Started guide that actually sets up a guestbook application with some Redis in the back. And I ran some chaos engineering experiments there, and it was like, what actually happens if I inject 20% of packet loss? I was thinking of like, I want to be really inclusive of the customer base that this guestbook was going to have, but I wanted to be thoughtful of like what actually happens to those users that are in countries where the internet is not as reliable. Yep. So I saw that like the experience was a little degraded, but it was actually still usable. So then I increased that blast radius and I went over to dropping 50% of our packets, and then you actually started seeing a little bit more of a degraded experience, but it was still usable. And then I went over and I started doing a latency experiment, and this was more of like, okay, my hypothesis is that if I inject 2,000 milliseconds of latency into my guestbook containers, well, I actually think that the application is going to behave quite well, everything's going to be working well. Well, there was basically like no good error codes for the user to know that like things were not loading properly as they were actually putting entries into this guestbook. They weren't getting any feedback that the UI actually got that input and was taking it in and saving it in the back. But then it got to like an even crazier experience where it's kind of like, hey, I'm running EKS, Kubernetes, there's like awesome reliability, and I just decided to like deploy Redis straight out of the box. And I'm like, okay, but what actually happens if I shut down my Redis primary container? Replica should automatically just get promoted to my primary and everything should work out seamlessly. Well, I went ahead and shut down that container, and sorry to tell you, data loss happened, and I was like, okay, this is really weird. Why is there like no replication? Why was there no failover? And I was able to like go look into like the Redis primary and the two replicas. They were all empty. And it was kind of like, I did a like Stack Overflow search of like, how do you actually manually promote like a replica to primary? And that was a lot of the way that people said to actually do failover. But when you're doing containers, it comes to the point that now your Redis primary has redeployed itself, and now the two replicas are looking at an empty container, and they're like, I'm going to copy that. And it becomes an empty container, so you actually end up losing everything. And it was like, how is it that out of the box, a tool like Redis wasn't able to provide us that reliability? So I got a chance to talk a little bit more about another use case for chaos engineering, which is actually being able to like put to test different like solutions of services, infrastructure, and be able to like say, can I use this in my company and is it reliable out of the box? What are some of the edge cases that it can actually lead for an outage internally?
On the topic of blast radius, user ABOM TV asks, any recommendations on chaos engineering for Kinesis streams and real-time data streaming? For example, how do you not lose data if we wipe a Kinesis stream?
I'll more broadly speak about just streaming data in general, right? Because I actually worked on it with a customer on a Kafka stream, it's a data stream, right? And there's a consumer app, and the consumer app processes these messages, and they had some experiments running on the consumer application. And so when they ran their experiment on the consumer application, it wasn't able to process the messages, and that was expected. And there's then becomes a backlog in your data stream, right? That happens. But what that customer learned there specifically is where they realize that their monitoring has gaps and they don't know how quickly their queue is growing. That's specific to their environment. I mean, obviously with Kinesis, there's all these metrics available, but it's like knowing where to go, knowing where to look for them, those would help. And so the question, if you remind me, the question was about
so I have data streams. How do I inject chaos into a data stream to uncover failures?
Yeah, so I think it has to do with blast radius in some sense, right? It doesn't have to be completely disconnect from your data stream. You can maybe inject just 100 millisecond latency to that stream first and see what happens. Yep. And then as you're ready, you can dial that up, right? So there are scenarios where it's too large of a blast radius. And you never want to start there, right? You should start small, and then we encourage you to step by step grow that blast radius so that you can get to the point of where things start to fall over.
And 100 milliseconds sounds small, but at Amazon, if we have a 100 millisecond increase in latency, that leads to 1% drop in sales across our site. That's a lot. So latency is a huge, huge thing to keep an eye on. Anna, a user only Dole wants to know, they say, hey Anna, 3 exclamation points. Any thoughts on what the next open source project is that you're going to try and take down? What's on your hit list?
So actually, I haven't created a hit list, but you know what? You can reach out to me on Twitter and hit me up with some like open source tools, and I'm super ready to go online and break some stuff and talk about it. So hit me up with suggestions.
They have one, so send that to her. I'm not going to shout it out on here. And if you want to know what it is, look in the Twitch chat.
But I have a couple of comments on that though, because a lot of people like using open source. It's great. But you actually don't know how every little piece functions. And so we actually have a customer that use Kubernetes. A lot of people use Kubernetes, but because you don't know the ins and outs of Kubernetes, they actually use this chaos engineering as a practice to learn more about the interactions and what happens if certain components starts failing. So like Kubernetes, there's plenty of other open source projects out there that people are taking advantage of, using, but this is a good way to actually learn more about what's actually in there, how it actually works.
Sully Neo, I love reading these names. Sully Neo is wondering, is chaos engineering catered more towards large cloud-based companies? What if you're a conventional model with a co-location data center? I feel like their company wouldn't be able to survive.
I can speak to a little bit more like the older times, right? Chaos engineering essentially is just, as I mentioned earlier, right, in the beginning of this chat, intentionally creating some failures. Yep. So it doesn't have to be cloud environment.
Well, it's much easier to survive if it is.
But that's true, absolutely true. There's a lot of benefits from doing cloud, but it doesn't have to be. When I say,
like even hesitate when they see the cloud, like, we'll go for it.
Right. But
we can still bring that down.
But exactly. So even in data center environments, or even a lot of people have multiple environments, right? They have cloud, they have on-prem, they might even have a closet data center if they do that. You can unplug cables, right? That's actually a form of chaos engineering. You are disconnecting something one server to another, and you want to know how your systems behave because of this disconnect in network connections. So it's not really an only cloud things. There's a lot more you can do in terms of resilience mechanisms and building resilience with the cloud environment, but this is not the only place that you can practice chaos engineering.
Perfect. There are many more questions that we can't get to, but I assume they can direct message you on Twitter or contact you. How quickly do people get up and going with Gremlin? Like if they go to the site, what's the lead-in time to get up and going and unleash your first Gremlin?
So you're actually able to deploy Gremlin into your host or your container within like 3 to 5 minutes. Very, very simple to like set up. Just get it started, connect it to like your infrastructure, and you're ready to start using experiments right out of the box.
Perfect. And what are your Twitter names so they know? I want them to send their questions over. There's some good ones in here.
So my Twitter handle is @Anna_M_Medina.
And my Twitter handle is @HoReal. So let me spell it out, because HOREAL.
Perfect.
That's my Twitter handle.
And you have a booth set up here, so if you're at reInvent, come check them out in the expo hall. And both of you, thank you very much, and keep the gremlins angry.
Thank you.
Stay tuned, we have more coming up.